Do you have your review? Do you have your review?
So we are going to do 77 on the word problems page and then move on. 77. Because the other ones are similar, and we did 76. So 76 is different because it's comparing two different things that don't relate to each other. Nickels and dimes have no real effect on each other except the total that affects that. Whereas in the other, everything else, there was either some slope, some y-intercept, some input-output that affected each other. This is not the same. So in this, we'll have 5 different variables. I'm going to label those off to the side. A, B, X, Y, and Z. Let's go and underline some things that are important. We're talking about nickels and dimes. That could change if you have a different type of problem. You know we are dealing with 2 different things, which is how it would tell you this is the format you're going to use. Your equation is going to be written in the format AX plus BY equals C. This is the equation for comparing 2 different things, the 2 different variables. C is usually your total, and it tells us the total value. I'm going to put that here. X and Y are usually the things you don't know. So here we're looking for number of nickels, which means Y would be number, or whichever one. The other one would be number of dimes. So if I say X is number of nickels, Y would be number of dimes, but we're told how many dimes there are, 46. Then whatever A and B are have to relate to X and Y. So A has to be something connected to nickels. It doesn't say this, but A would be the value of the nickels. And then B would be the value of the dimes. So then taking all of those numbers, you would put it in that equation, that AX plus BY equals C. 0.05, X just stays X, plus 0.10, Y is 46, and it equals 545. Then you would start to solve for X. Multiply the 0.10 and the 46.
4.6.
Subtract it on both sides. If you don't have your calculators, so grab that. And divide both sides by 0.5. 0.05, sorry.
17.
And label it because we're looking for specific thing, so 17 nickels. Do we have any questions about that? Go on to the next page. So now we are in systems. First one is solving systems by graphing. Which of these do we want to see? Do you go over and have questions about?
How about 80?
78. Start with those. Okay, so here we're going to graph both lines and see where they cross. For the first one, start at -4 on the y-axis. Your slope is -2. So for negative slopes, you can go up and left or down and right. I'm going to write that off to the side. So we can't go down 2, but we can go up 2, and this is over 1. So up 2, left 1, as many times as possible. And graph that line, draw arrows at the end. Your other equation is a y equals, so you have to remember your point bucks. So since this is a y equals, it's going to be a horizontal line starting at -2. So on the y-axis, find -2, draw a point, draw a horizontal left and right line through it. And then you're looking for where do those two lines intersect or cross, and you would write that as the order here. X and then Y. Question on that one before we do the next one? For 80, you're doing the same thing. I'm starting with this first one. Y-intercept of -1. The slope is now positive. So for positive slopes, you can go up and right or down and left. So keep going up 3 to the right 2 as many times as possible. And then go down 3, left 2 from your y-intercept. Draw a line through those points, connect the dots, draw arrows. Then you're going to do the same thing for the other one. This one's going to start at +3 on the y-axis. The slope is the same. So if I went off the graph, then I'd have a point here. Otherwise, I can go down 3 and left 2 a couple times. Draw the line through those points. Do these lines cross?
Nope.
No. So this would be no solution. questions on that one? (82), we have to solve both of these. Get it back into y equals mx plus b. So we can get rid of the x for both, subtract them. I'm going to do this simultaneously, subtract the x on both at the same time. The first one would have negative 3y equals negative x minus 6. The second one would be similar, but a little different. Negative 3y equals negative x plus 6. And then divide everything by negative 3. Your slope is going to be a fraction for both. The first one would be positive 1/3 x plus 2. The second one would be positive 1/3 x minus 2. These again have the same slope, so they'll be parallel lines, so it'll be no solution. But we still have to graph it. It doesn't matter which one you graph first. I'm going to graph the bottom one. Starting at negative 2, going up 1 to the right 3, down 1 to the left 3. Connect those points, draw a line through it. And the other one would start at positive 2. Same slope, up 1, right 3, down 1, left 3. We can see that they don't ever cross, so no solution. Other questions on this page? Once you have that written down, go on to the next one. Now we are doing systems by substitution.
85. How about 90?
(87). So start with 85. If you had an x or a y that equals either a number or an equation, you would take that and put it into the other one. So here, because we only have a number, you're going to take that number and put it in for the other y. Negative 2x minus 2 times 7 equals negative 14. And you would use that to solve for x. Get x by itself by adding 14 to the other side. And dividing both sides by negative. If you had put in an equation instead of just a number, you would have to go back and find the other variable, but in this case, we have our x, we have our y, write that as the order there. Questions on that one? 87, similar, but it's a whole equation. So this is a y equals already. Take this, put it into the other equation where y is, and rewrite it. So negative 7x minus 7, then in parentheses, negative 6x minus 17 equals negative 2. Then you are solving distribute.
One 119.
Combine your like terms and then start to solve for x. Get rid of the 119, subtract it to the other side.
Negative 140.
And divide both sides by 35.
Negative 4.
So that's one part of it. We found x, but now we have to go back and find y. So we're going to take that number we found and put that into the equation that we were given where x is. So we have y equals negative 6 times negative 4 minus 17. Then you could use that, find your y value. And write those as a order here. Any questions on that one? $88 does not have an equation that's solved already, so you would have to do that first. You can really choose any of these variables, but some might work out better than others. If you look for something that was by itself, that would work every time. So get rid of the 5y, add it to the other side. Then you have an equation by itself, and you can take that equation and put it into the other one where x is. So we have 5 times 17 plus 5y minus 5y equals negative 2. And then you could start to solve.
Uh, 85.
85 plus 25y minus 5y equals negative 15. Combine your like terms. 85 plus 20 plus 20. Subtract 85 to the other side.
Negative 100.
And divide both sides by 20. Similar to the last one, we have a part of the answer. We have y. We have to go back and find x. By taking that number, putting it into the equation we found, but where y is. So X equals 17 plus 5 times negative 5. Then even though we solve for y first, it's still x first, negative 8, negative 5. $90 is the same way. 90 and 91 are the same way. So find the variable that's by itself, get that by itself by subtracting 5y to the other side. Taking that equation, putting it back into the other, where x is. 6 times negative 1 minus 5y plus 6y equals negative 6. Distribute, start to solve for y. Combine your terms so you get negative 24y. Add 6 to both sides. And keep going. Even though it's equal to 0, you can still keep going. So that y is 0. Once you find y, go back and find x. I can put 0 in to this original equation. X equals negative 1 minus 5 times 0. Or just negative 1. Negative 1, 0 would be that answer. And then last one, 91. Get this x by itself. Add 3y to the other side. Put that equation into the other. Where this x is. Distribute and start solving for y. Have 15 minus 8y equals 23. Subtract 15 to the other side. And divide. And then take that y value and put it back in for x. Sorry, put it back in for y to find x. So we have negative 3 minus 3 or negative 6. Negative 6, negative 1 would be that final have that, go on to the next page. Now we are solving systems by elimination, which is different than substitution. Pretend that isn't already there. Of those, which ones do we want to see? Do you go over?
About 94.
94. Okay.
Let's start with those two. If we have others, we'll go back. Okay. So with elimination, two things need to happen before you start. You need to have everything lined up, so x's on top of each other, constants, and then y's, not necessarily in that order. And then you're looking for which variable has the same coefficient. So from there, so we have to make these the same format. It would be easiest to really just rearrange this one. And then put 0 where the constant would be, because we don't have a constant. So we really just rearranged the top one, but added in a 0 because we didn't have that before. Not everything lines up.
Doesn't x have to 10?
Mm-hmm. It's supposed to be an x. Then you're looking for which one has the same common coefficient or the same number before the variable. The x's have that. Then you have to think about how could we eliminate that by adding or subtracting. 10 minus 10 will give us 0, so we're going to subtract the entire equation from the other. So we'll go in a row. -7 minus -5. Be careful with your negatives. This is really -7 plus 5.
-2.
12 minus 0 just becomes 12. 10 minus 10 is 0. So really, we can ignore the 0. Divide both sides by -2. And then we have our y. But we have to go back and find x. So you have two choices. Put this in the first one or the second one, doesn't matter. I'm going to put it in first. And then start to solve for x. 10x equals 30. Divide both sides by 10. And then write that as a order. Questions on that before we go on to the next one? Okay. 99, they're already lined up, x's, y's, constants, but we don't have the same common coefficient, so we need to either make the x's the same or make the y's the same, not both. Does not matter which one. Let's say I wanted to make the x's the same. If you can't think of any number they both go into, you can always just multiply them by each other. Multiply this row by 6 or negative 6, and then multiply the other one by 10 or negative 10. So both equations would change. We have 60x minus 48y equals whatever that is.
Negative 168.
And then negative 60x plus 100y equals negative 300. Now our x's are similar. They're not the exact same, but that's okay. And we have to figure out how to eliminate 60 plus a negative 60 would eliminate, so I could add the two equations together. So 60 plus a negative 60 would just become 0. Negative 48 plus 100 would be
52 plus.
and then negative 168 plus a negative 300 would be 468. And then divide both sides by 52.
Are we adding? Or?
Yes, but if you added a negative, you would still be subtracting. So then we can go back and find x. So you have choices. Put this into any of these 4 equations and solve for x. I'm going to do the first one. If you chose a different one, that's fine. You should still get the same answer. Divide both sides by 10, and x is negative 1. So our ordered pair would be negative 1, negative 9.
Wait, what is x equal to 10?
Yes, I don't know why. Yes, that's what it should have been. I just saw one of the zeros go away and not the other. Any other questions on this page that we want to see you go over?
So, like, what we have left to cover is kind of driving me crazy. Like, it's like, oh.
I don't think about that.
We just like barely touched the packet. This is all.
So I'm hoping if we could get through 3 and 4 today, that would be good. We may not get through everything, and that's okay, but trying to get through as much as possible in the time we have. All right, go on to the next page. So last thing in Unit 3, solving word problems, systems of word problems. So which of those do we want to see you go over, have questions about? Did you say 1? Did you say 1? 101. I will say 100, 102, 103, and 104 would be set up very much the same way. 101 would be different. As with all word problems, look for important pieces of information. Any numbers you see will most likely be important. And the questions it's asking. So skipping through some of this, I see 13 packages of chocolate chip cookie dough, 6 packages of double chocolate chip cookie dough, and then a total of 138. And then 10, 4, and a total of 100. And we are looking for 2 things: cost of each type. So before we do anything else, we need 2 variables. The question is going to help you with that. The cost of each type, so you can call it C and D, X and Y, whatever you want. It just has to be 2 different variables. And we have to be specific about what these represent. So our question said cost of, so that would be what these are defined as. Cost of chocolate chip cookie dough and cost of double chocolate cookie dough. It's a lot of, that's a mouthful. When you are given 6 numbers like this one, you're going to use all 6. The totals you can put at the ends. So you know one's going to equal 138 and the other 100. The number of packages is going to go with the variable's cost. So 13 would go with C, 6 would go with D, and we're looking for total, so I'll add. And then same thing with the other one, 10C plus 4D. Then you have choices of how you want to solve, by graphing, by substitution, by elimination. Some problems work better than others with certain types. This would be a good elimination problem because you could easily change this to be the same. So I know these both go into 12, so I could multiply the first one by 2 and the second one by 3. So 26C plus 12B equals
276.
And then 30C plus 12B equals 300. Then to get rid of the D's, we would subtract. 12 minus 12 would give us 0. So we could eliminate. We have negative 4C plus 0 equals 24. Negative 24. And divide both sides by negative 1.
It's positive 6.
Because we're looking for costs, our label would be dollars. But then we still have to find the cost of D. You can put 6 into any of these 4 equations and solve. I'm going to choose this one. We have 60 plus 4D equals 100. Get rid of 60. And divide both sides by 4. In some of your word problems, double check your answers. It may make more sense for like one to be more expensive than the other. And this one I could say double chocolate is probably more rare than chocolate chip, so it's probably more expensive. I'm assuming, I don't know if that's the real reason. Questions on that one before we do 101? In 101, important things are with a tailwind, 104. Talk about those words here in a moment. And then on the return trip, 66 for flying back into the same wind. The return trip is not really important. We need to find the speed of the wind and the speed of the plane. So your two variables, we could be P and W, X and Y, doesn't matter. And that will be what we don't know, speed of each. In this case, with a tailwind, that means the wind is helping the plane move, it's pushing it forward. So that's going to be a plus. And we know it's going to equal 104. If it's flying back into that same wind, the push it was getting helped with is no longer there, so now it's minus. We aren't given, equals 66. We aren't given any other numbers, so we're not putting in extra numbers that aren't there. So we're just going to use the variables, P plus W and P minus W. Because in the second one, we're not getting that wind, so we have to subtract them. This would be a good any type. So which way do we want to solve this? Graphing, substitution, elimination.
Which is quickest?
Elimination. So if we wanted to eliminate these, either the P or the W does not matter. We could either subtract the P's or add the W's. Let's just say we're subtracting. So then W minus a negative W would be negative 2W. What's 104 minus 66?
38.
Oh, that wasn't negative. That was my bad. W minus a negative W would be positive. Divide both sides by 2. So this would be 19, but our label would be kilometers per hour. And then you would put that back into one of the equations and solve for P. What would P be? This would be another one where look at your answers, because if your wind is going faster than your plane, there's probably an issue there. Questions on that, or other questions on this page? Go on to the next. So now we are in Unit 4, solving inequalities. Which of these do we want to see, do go over, and have questions about?
I guess 112.
Really, if you could do questions like 112, that covers basically everything. But we'll start with 108. Just like regular equations, we have to get the variable by itself. So distribute. Add 21 to both sides. Divide both sides by negative. Because we're dividing by a negative, the sign is going to change directions. So you could leave this as is, you just have to read it backwards. A, look at if it's pointing away or to it, it's pointing away, so that's greater than or equal to 5. Or you could flip the whole thing. Make sure it's still pointing in that same direction, either towards the A or away from it. So this will be closed at 5, going to the right. Questions on that one? One 12, similar, but you have to distribute twice. You have negative 6 minus 7k minus 7 is less than negative 5 minus 15k. Combine like terms on the same side, the negative 6 and the negative 7. Then, just like your equations, you have choices. Pick something to move to one side, and then the opposite to move to the other. So let's say I added 15k, and then added 13. We would divide both sides by 8. So that k is less than 1. So this will be open to the left. Other questions? It goes to the right. Yes. Go on to the next page. So this should be somewhat familiar because we were just doing compound inequalities with Unit 9, and then again in our Unit 10 when we were doing absolute value inequalities. Which of these do we want to see, do you go over or have questions about?
119.
119. That makes more sense. Another 114 left. 120. These are all words. Do we want to change one to an and? Instead of 114, 116, everything is in one equation, one inequality, so you know it's and. You're trying to get the x in the middle by itself, so get rid of everything else by doing it to all sides. So add 3 to everything, except the negative 9. Divide everything by negative 9. Because we're dividing by a negative, all the signs are going to change directions. But you'll have to take the whole thing and flip it back because it needs to be least to greatest with less than or less than or equal to. Because this is an and, they're going to face each other. So these would both be open circles at -7, at +8, and there would be a line connecting them. This is not least to greatest. And then 119 is an or. So we're going to solve those separately. I'm going to rewrite them so that I have more space to work. If you rewrite them, make sure you write down everything. If you miss anything, you'll mess up the problem, one side of the problem, and then the answer. Right? Pick a side, solve that one, and then pick the other side and solve that one. So for this side, if I'm trying to get the variables on the same side, I could remove 4n and add 4. Divide both sides by 14. And then solve the other side. Here, let's say I want to get rid of 2n by subtracting it, and then subtracting 7. We have n is less than -9. When you don't have anything else, make sure you put an or in between them. Or means they're graphing away from each other. So this one would be closed at 1 going to the right. This one would be open at -9 going to the left. Questions on that one before we do 20? Okay, I'm going to rewrite that one as well. And do the same thing. One side, solve that, then do the other. I could subtract 9r and add 5. And then focus on the other side. Say I subtracted 3r and added 9. The 9 here would cancel. Become 0. Wait, keep going. Divide both sides by 3. So again, it's or, so they're going to face away from each other. These are both going to be open. 1 at 0, 1 at 10. 10 going to the left, to the right. 0 is going to the left. to the next page. If we get through 4, all of 4, then we'll stop and be done for today. Find questions you want to see, do, go over on 4.3.
I guess 122.
So let's start with 122. It is a y inequality without any x's. We have to use toy bucks. Because it is y, it's going to be horizontal at -5, so place a dot at -5 on the y-axis. Because this is less than or equal to, this is going to be a solid line shaded below. So we're going to draw a solid horizontal line across. And underneath that line, we're going to shade. Questions on that one? (124), we have to solve this. Get it back in slope-intercept form, subtract 5x to both sides. Divide everything by 4. And then, just like graphing in general, start at your y-intercept, -5. This is a greater than, so it's going to be a dashed line shaded above. Our slope is negative, so we can go up 5, left 4. If you go another one, it'll be off the graph. Not for you to cut all of this. Right in. If you're not sure which way is above, look at the y-intercept, draw a little up and down arrow. Up would be above, down would be below, so this entire area is going to be above. And then next objective. Is your systems of inequalities. Which of those would we like to see you go over?
127.
Okay, let's start with those two. I would use 2 different colors or writing utensils for these. For this first one, this is greater than or equal to, so it's going to be solid, shaded above. Start that equation at 2. We can go up 5 to the right 2, or down 5 to the left 2. draw a line that connects those two. And above that line, we could do the same thing, y-intercept, draw up and down arrow, up would be up to this area. The y inequality is similar to what we just did, using your $20. It's going to be a horizontal line. This is going to be dashed and above. Put a dot at -3. Make it a dashed line across. And then shade above that line. If you were using the same color or like pencil, you could highlight the section that overlaps. Questions on that one before we do 132? For 132, we'll have to solve both of these first. Subtract 2x to both. First one would be y is greater than or equal to -2x plus 3. Second one is y is greater than -2x minus 1. So then graph those both. I'm going to start with the one in orange. Starting at -1, this is dashed and above. Slope is -2, so we can go, up to left 1, down to right 1. And you can either make this dashed or dotted, so either put little tick marks in between, or just draw arrows at the end. Above this line, if I look at the y-intercept and draw up and down arrows, above would be up, so all of this. And then I can do the same thing for the other one. Start at +3, my slope again is negative, up to left 1, down to right 1. This one is greater than or equal to, so it's solid and above. So connect those. And above would be again to the right. So the overlapping would be this area over here. Do you have any other questions on this page? So Thursday is really the last day for us to do these together. We'll try to do as much as we can, but we probably won't get through everything because Monday is you guys' exam.
Oh, it's
Yes, it's
Oh.
Monday. So the time, it'll be 6 period finals, and then 7 period finals, and then 5th period, and then 3rd period. It'll be such a weird day. So no first period at all.
Wait, is it finals for all of those classes?
It's only finals for 6 and 7. So just 6 and 7.
So this is period 7, right?
Yes. So, Eva. Second. 6 and 7. 5 and 3. It should have been posted. But mine is on Canvas. There's also that behind you.
Oh, so I started over there in my computer. Oh. And I have the final for that class as well.
So I would say keep working through these, keep checking your answers on Canvas. Come to see me before, after school if you want to go through problems together. If you still need to retake, any of those things. This class is going to draw names Thursday since I won't see some of you Monday.
He's just up every chapter.